Hello students. Hello all. This is Dr. M.D. Samir working as Assistant Professor in the Department of Mechanical Engineering, CATIA Institute of Technology and Science, Warangal. I welcome you all for the workshop practice laboratory, the course code U18ME109 and U18ME209. In this particular uh, video session, we will be seeing what is fitting and the experiment number 2, how to prepare a half round fit. The objective of this experiment will be that student will develop knowledge on preparation of joints using fitting, and outcome would be upon completion of this experiment, student will be able to perform various joints in fitting, especially the half round fit. Introduction. The bench work plays an important role in engineering practices. So fitting is a process of assembling various parts manufactured in the machine shop. The parts finished in machining operations often require hand operations to obtain desired finish and fit. And these operations are usually performed on bench. Therefore, it is called as bench work. Experimental details. The experiment number is 2, that is E2. The name of the job is half round fit. The objective of this experiment is to make a half round fit. The materials required is mild steel plates of dimensions length 40 mm, width 40 mm, thickness 3 mm. Quantity required is 2. This is the diagram of the two metal pieces that we need to manufacture in our workshop. The first plate is of dimension of height 28 mm and of length of a half round at the center of the metal piece with the radius 10 mm, and the both sides having a flat length of 9 mm and 9 mm each. The total length of the metal piece is 38 mm, whereas the other half of the metal plate, that is mild steel, it consists of the length of 38 mm and height 38 mm and the same radius of 10 mm inside in this particular mild steel plate. Tools and equipment required. We require a bench vise, a surface plate, a height gauge, a center punch, flat rough file, tri-square, hacksaw frame with blade, ball peen hammer, chisels, divider, and angle plate. Bench vise, generally bench vise, this is fitted onto a bench, a wooden bench. This consists of two jaws. One is called as fixed jaw, the other is called as a movable jaw. The material that has to be machined is fixed in these two jaws, and the tightening of the bench vise is done with the help of a handle, and this total setup is fixed to a bench. And here we can, in this diagram, we can see there is a hole for fixing this vise. So this particular equipment is called as a bench vise. We require a surface plate. Surface plate generally it is used for the flatness, to check the flatness of the workpiece, and it has very fine limits of the surfaces. The material generally used for the surface plate is cast iron. Here we have a another tool that is called as vernier height gauge. This vernier height gauge is clamped with a scriber, and it is used to mark the layout on the metal pieces that we machine. Here it consists of a scale which includes an inch scale and also a scale in centimeters and mm. It is made to stand on a base. It consists of the, the screws which are used to fix the scale, and it consists of a scriber to mark the length on the metal. So these are done vertically, and with the help of a scriber the markings are done on the metal piece. We also utilize the punches. We have two types of punches. The punches are used on the metal pieces to make the indentation so that the markings which are scribed on the metal are clearly visible. So we have two types of punches, that is dot punch and a center punch. Dot punch is having the included angle of 60 degrees, whereas center punch is having the point of included angle 90 degrees. The dot punch is used for very slight markings, where in order to locate the centers for the circles or arcs, whereas the center punch is used to make very thick indentations on the metal piece. So they have the knurlings on the surface of their cylindrical body. We also use files. The files generally consist of the length, tang and handle. These are the different parts of the file. It has edge and different cutting points, and the face, we have the face, we call it to use it to remove the material from the metal, and the heel is used to insert in the handle. So these files act as a multi-point cutting tool which are used to remove small quantity of material from the metal workpieces. There are different types of files we use in our fitting. The single cut file, double cut file, rasp cut file are the examples based upon the, the number of cuts on the faces. The single cut file is of having one diagonal parallel lines on the faces. A single diagonal lines are parallel lines on the faces, whereas double cut file is having the parallel lines in both the direction, whereas single cut file is only in single direction, whereas double cut file the parallel lines are in both the directions. The single cut file is for rough filing, whereas double cut file we can use it for the smooth filing. Rasp cut file, this is a kind of a filing where we can remove more material with a rough surface. We have different types of files based upon the, the nature or the shape of the file, that is flat file or hand file. Hand file is a single cut file with the uh, with the with the rows in single direction which are acting as the cutting points, and flat file is a general purpose file where we can use it to remove the metal from the metal from the workpieces. Triangle file is a triangle in shape which we can remove the material from the corners of the material or the metals where the material has to be removed. We use round files to make the concave surfaces, filing to make the filing of the concave surfaces. We use square files also to have the sharp corners, to remove the materials in the sharp corners. So these are different types of files. One is hand file, flat file, triangular file, round file, and square file. The other materials we use in this particular in the experiment is tri-square, which consists of a beam and a blade. This particular tri-square is used to check the squareness of the metal, that is its surfaces, are they perpendicular to each other or not. We check its squareness and its perpendicularity, and whether they are in full contact at the corner or not, we'll check with the tri-square. We'll use a saw frame with blade, a handsaw, hacksaw frame with blade. It consists of a blade, a frame, and a handle, and a wing nut to adjust the tightness of the blade. The blades are staggered in nature. When we do the sawing operation on the material removed, the groove obtained is more than the width of the blade. That's the reason why we have the staggeredness of the teeth. We use ball peen hammer for chipping of the material to remove the material, and a ball peen hammer consists of a face where a flat face where it is used for removing, chipping, and the ball peen at the other end is used for riveting. It consists of handle and a keyhole to insert the handle, and the the side above the face we call it as the pole. We have different types of hammers. One is called as cross peen hammer, the other is called as straight peen hammer. Cross peen hammer, the peen is perpendicular to the handle, and straight peen hammer is the peen is in line with the handle. Here both the hammers are used for chipping of the material, hammering the material, or for riveting. We also use chisels in this particular experiment. Chisels are used to remove the material from the thin sheet metals, or to make holes, or to make bends on the material. So there are different types of chisels. One is flat chisel, cape chisel, half round chisel, and diamond point chisel. Flat chisels are generally used chisel to remove the material from the metal pieces or the thin metal sheets. They have the included angle of 60 degrees at the end of the chisel. There is another type of chisel called as cape chisel. The another name for cape chisel is a cross-cut chisel. It is used for cutting the channels on the large surfaces. And we have half round chisel, which is used for trimming the fillet corners. We have diamond chisels, which is used for cutting V grooves and sharp corners. So any chisel will consist of head portion, a shank portion, and a point portion. These are the parts of a chisel. We also use odd leg caliper and divider. The odd leg caliper is used to mark the radiuses or the arcs or the circles on the metal pieces, where this odd leg caliper consists of a bent leg and a straight leg. Bent leg is fixed to the edge of the workpiece, and straight leg used to mark the, the scribing on the metal workpiece. And we also use divider to mark the centers and the circles on the metal pieces. In these experiments, we follow the sequence of operations. The first operation is filing, second is dimensioning, third is marking, fourth is chiseling, five is filing using square and flat files, sixth is assembly or fitting. Let us see the video of how to perform this particular experiment. Here you can see different types of files, tri-squares. So these are the two metal pieces where we have to perform this particular experiment called as half round fit. So this is the flat file, this is the half round file or round file, this is the triangular file, this is the center punch, ball peen hammer, divider, steel rule, hacksaw frame with blade, tri-square. We'll take the two metal pieces. The first metal piece is inserted in the bench wise and we'll do the flat rough filing. This flat rough filing is made, and then with the help of this the tri-square we check the squareness of the metal or the perpendicular of the metal. If there is any deviation in the dimension when it is not perpendicular, we again do the filing with the help of a bench wise. So this tri-square is continuously used in the filing section to check the accurate dimension of the workpiece. Again, we'll try to check the squareness of the workpiece. I think now it's okay. Then we will insert another mild steel workpiece into the bench wise and we'll file it again with the help of a flat rough file and check with the tri-square. There is a little gap here in this metal when measured with the tri-square. Then again we'll insert in the bench wise and we'll do filing. So filing has to be done carefully such that the required amount of material in the required quantity has to be removed such that it is squared or perpendicular. So as you can see, the filing here is done with the rough file where the small quantity of material is being removed. Now after doing filing, we will apply chalk on one side of the workpiece. So this chalk, we can use a wet chalk and we can apply on the both sides of the metal pieces. So we require here surface plate, an angle plate and a vernier height gauge. So as discussed in the previous slides, this vernier height gauge will consist of inch scale and centimeters or millimeter scale on the other side. It consists of a knob. The zero should coincide with the main scale of the vernier height gauge. That gives us the final dimension of the material. So we should check where this zero of the scale vernier is coinciding on the main scale. So here we can clearly observe that if we require a 40 mm length on the material workpiece that we have to mark on the given workpiece, then we have to adjust that zero to that particular height and we have to fix it. Then we have to make it stand on its base, then we can see our dimensions. What is the dimension given for us? Based upon dimensions, we should mark our length on the workpiece. So here, the how much length we want to mark on the workpiece is already fixed, and we are scribing it on the metal workpiece where the chalk is being applied. Now after scribing with the help of vernier height gauge, we have to take the center punch, and further we have to mark the its indentation throughout the scribed area. First we are marking the centers in order to make the semicircle that is half round on the metal. As you all aware that the center should have the radius of 10. So the 10 radius is measured, and center is marked with the help of a center punch, and the radius is scribed on the surface of the mild steel plate where the chalk is applied. Now we can see the half circle, the half round marked on the mild steel. The same half round is marked on the other mild steel workpiece. So one will be outside, one half round will be outside, and another half round will be inside. Now we will take the center punch, and along the circle, the half circle, we will put the indentations using the center punch. So the indentations are punched on the semicircle on both the plates here. Then you can scribe the amount of material that has to be removed. So we can't remove the material just in that particular shape at once. So material has to be removed in phase wise. First we are removing the material with a given amount of material linearly. So we can't remove the material in the shape that is being scribed on the metal workpiece. So for that purpose, what we have to do, we have to incline the workpiece in the bench wise such that the hands-on operation can be performed easily. If the blade is bent during this operation, the blade will break down. So we have to see that the blade is used in the sawing operation should be in a straight direction. Now the excess amount of material has been removed with the help of handsaw. Now the inner circle, the inner half round is made with the help of a half round file. So half round files are generally used to make the inner circles, the given radius. Then we will take the other half of the half round. This milestone in this particular workpiece, we have to remove the materials from both the sides such that we have the half round at the middle or at the center of the workpiece. So the major part of the material has been removed with the help of a hacksaw. So this way we will use handsaw to remove the material on both the sides. Now with the help of a ball peen hammer, we'll try to remove the material which is being cut with the help of handsaw. So this process, we call it as chipping. The material has to be chipped so that it will easily come off the workpiece after machining. Precautions must be taken during the machining in the workshop. The handsaw the handsaw must be held properly, the tight grip such that you avoid injuring your fingers. Now here we can see that again the metal workpiece is inserted in the bench wise. In this bench wise, we use again different files to make the circular, round, outward projection. So here we do not have any tools to make it circular projection outwards, just like half round fit where we can make a circular projections inside. So for this, we need to use the hand tools like a flat rough file to remove the material in small quantities and to make it into a round shape. And we can use the triangular files also for smoothing purposes because it consists of a corner. The half round it consisting of a corner at one side and the another corner at the other side. So to make that corner smooth, so we can use the triangular file. Now we are using the triangular file again at on the other side. So like this, we have to file the two workpieces, and then we need to check whether the half round that we have made is fitting inside the other half round of, of the mild steel plate. So if there is any difference in the fitting, again we need to do the proper filing, and finally we can fit the two pieces, that is half round fit into an assembly. Now here we can see that we have made the half round fit. So that was about the experiment, how to be performed in the laboratory. Now once again I'll come to the procedure. So keep the given workpiece in the bench wise and file the edges of the piece using flat rough file. Check the perpendicularity and flatness of the plates using tri-square. Apply chalk on one side of the given piece. Keep the given workpiece on the surface plate and mark it to the dimensions as per drawing. Punch along the marking with the help of the center punch. File all four sides of the workpiece with the help of flat rough file to the exact punched marked dimensions. Cut the workpiece using chisel along the marked dimensions. You can use chisels if the material can be removed with the help of a chisel. Put the workpiece in the vise and cut to the exact marked dimensions using hand hacksaw. So that is the procedure again where we have recapped as the summary. Now the precautions is that we have to wear apron while performing the experiment. Marking should be carefully done. We should check the perpendicularity of the workpieces always with the help of the tri-square. Fix the workpiece into the vise and the vibrations and noise should be avoided by fixing it firmly in the vise, that is bench vise. Handle the tools carefully. The hand hacksaw, the hammer, the filing that we do while we machine. So they should be used very carefully. The, the applications of this particular experiment is that this can be used in job type production where the products are made with the help of different hand tools, and we can use it for making door and window hinges, in the assembly of different machine tools, jigs, gauges, and manufacturing of prototypes, etc. So during the lab session, the students are expected to write the viva questions in the manual that they have supplied with. What for odd leg calipers is used? What is the angle of what is the point angle of center punch? What is the point angle of dot punch? What for angle plate is used? What for scriber is used? Differentiate between single cut and double cut files. Name the different types of hammers used in fitting work. What are different types of chisels used in fitting? What is the function of cape chisel? And what for divider is used? And the record work that student is expected to complete in his laboratory manual is the objective of the experiment, the diagram of the experiment that is performed, tools and equipment required and the purpose, sequence of operation, interpretations of the results and discussion, and what the student has learned from this experiment based on the objectives, and how will you apply the knowledge gained by performing this experiment in future, and what are the suggestions on alternative approach of this experiment. How can this experiment be performed in alternative approach? What are your suggestions on extension of this experiment? Can this experiment be extended to improve students learning experience? So these are the questions that students need to put their thoughts in their own in their manual. And viva voce is being performed at the end of the experiment. So continuous internal evaluation, it consists of 40 marks, which includes 10 marks for the knowledge. The student who is coming for the lab is expected to have the knowledge, the prerequisite knowledge on the experiment to be performed. The participation, P represents participation, K represents knowledge, whether how the student is taking part in the performing of experiment. W is for write up, how the viva questions are written and what are different suggestions made, and the viva, how the student has answered the oral viva voice questions. So it consists of total 40 marks. So with this, I conclude this experiment, that is making the half round fit. So students, I wish you all the best. Perform this experiment in our workshop laboratory. Happy learning. Thank you all.